Question number 1. For image formation by a concave mirror, which of the following statement is correct? Or the center of the curvature, the size of the image is the same as the sum of the object. A concave mirror forms an image of that object when the object is placed at the center of curvature. Nature of the image formed at the center of curvature is inverted and same size as the object. The image is found at the same position object but on the opposite side of the mirror. This is due to the symmetrical property of the concave mirror, where the light ray originating from the object at the center of the curvature reflects back and converge at the same point. The position of the image at its fixed in a concave mirror depends on the object's placement concerning the mirror's principal focus and the nature of the image is real and erect, and the object is at the center of curvature. And the object at the center of curvature, the image is real and inverted, not erect. In concave mirrors, real images are erect images can only be found when the image is virtual, which occurs when the object is placed between the focus and the mirror. An object placed at the focus forms a highly diminished image. When an object is placed at the focus of a concave mirror, the reflected rays become parallel and do not converge to form a finite image. The image is found at infinity and is highly magnified, not diminished. The size of the image is enlarged when the subject is placed at infinity. When an object is placed at infinity, the image formed by concave mirror is highly diminished, real and inverted. The image is found at the focus of the mirror and its size is considerably smaller than the object. Concave mirror is a spherical mirror with the reflective surface curved inward. It can form real or virtual images depending on the object's position related to focus and the center of curvature. Concave mirrors are widely used in telescope, headlights, and side mirror due to their ability to converge light rays. Question 2. What is the main cause of energy loss in transformer? Hysteresis and eddy current. Hysteresis loss occurs in the transformer due to the repeated magnetization and demagnetization of the core material as the alternating current flows through the transformer. The energy lost in the form of heat. Eddy current loss arises when the alternating magnetic field induces circulating currents, eddy current in the core material. These currents result in energy dissipation as heat. Both these losses are collectively referred as the core loss of the transformer. The magnitude of hysteresis loss depends on the material, its magnetic properties, and the frequency of the alternating current. Eddy current loss is minimized by using a laminated core, which increases the electrical resistance of the core and reduces the magnetic eddy current. Hysteresis and eddy current losses are important consideration in transformation. Designed to improve its efficiency. Additionally, when one surface lights over another, it is not a major factor in energy loss within a transformer since the transformer does not involve any moving parts. Thermal expansion. Thermal expansion refers to the physical expansion of materials. When subjected to heat, all the transformer can heat up during operation. Thermal expansion does not directly contribute to energy loss. Gravity is the force of attraction between masses. It is not relevant in the context of energy loss transfer. When a boxer moves his head backward while receiving a punch, the impulse received by his head decreases. Impulse is a product of force and the time duration for which the force acts. It is related to the change in the moment of an object. Mathematically, impulse can be expressed as impulse equal to force into time equal to change in momentum. When a force acts as an object for longer, the impulse increases. Conversely, the interaction time increases, the force experience decreases. When a boxer moves his head backward or receiving, but the duration of inflection time between the punch and the head increases. As the reaction time increases, the force exerted to the punch and the decreases. Impulse is the product of force and time. As the force decreases due to the increasing reaction time, the volume of the head decreases. Which one is not correct about example of electromagnetic wave? Supersonic waves. Supersonic wave, these waves are faster than the speed of sound. When a plane travels faster than the speed of sound, the plane breaks the sound. Therein produce a loud sound. This is called sonic boom. So, an example of sonic wave. The sonic waves are created as a result of vibration between the electric and magnetic field. Where you can say that is composed of oscillating magnetic and electric fields. EM waves are radio waves, microwaves, infrared light, ultraviolet, X-ray, and gamma rays. Depending on the variation in wavelength and frequency of different applications. X-ray waves are produced by selecting electrons. These are used to view the images of bones and other structures in the body. Gamma rays are emitted by the nucleus of the some radionuclides following radioactive decay. These are used in medicine, radiotherapy, industry. Sterilization and disinfection. The nuclear industry ultraviolet radiation is widely used in industrial process and in medical and dental practice for a variety of purposes such as killing bacteria, creating pollution efficient, curing inks and resins, phototherapy, and soothing. Helium is added to the oxygen supply of deep sea divers because it is less soluble in blood than nitrogen at higher pressure. Helium is added to the oxygen supply of deep sea divers because it is less soluble in blood compared to nitrogen at high pressure. At high pressure experience during deep sea diving, nitrogen dissolves more readily into blood readily, leading to nitrogen narcosis, which can impair judgment and motor skills. Helium's low solubility so the risk of decompression sickness, also known as burns, that is not form bubbles during ascent. Helium is chemically inert and does not react with body tissues, making it a safer alternative to nitrogen breathing mixture of facilitated easy breathing, especially at high pressure. Breathing gas mixture for deep sea diving. Deep sea divers use breathing gas mixture like helium, oxygen, primates, helium, oxygen, nitrogen to avoid issues like nitrogen acidosis and decompression sickness. These are carefully designed to ensure safety varying depths and pressure. Helium's physical and chemical properties make it an essential component of these mixtures. 2PU plus C2PU is due to which natural reaction. Redox reaction is a reaction to simultaneous process. Oxidation and loss of electron reaction with gains of electron. 2Pb plus CO2Pb CO2. Lead oxide is Pb is reduced to lead with gains electron. So reduction. Carbon is oxidized to carbon dioxide, so it loses electrons. Carbon is getting oxide because it loses electrons and forms CO2. Lead oxide is being reduced because it gains electrons and forms Pb. The substance described below is a single atomic layer of carbon arranged in hexagon. It is strong, lightweight, conducive, and used in nanotechnology and flexible electronic materials. Fluorine, graphene. Graphene is a single layer of carbon atom arranged in two-dimensional honeycomb lattice. It is known for exceptional strength, being approximately those two times stronger than steel. Graphene is lightweight and highly conducive, making it ideal for application in electronics, nanotechnology, and energy storage. Its flexibility and transparency make it suitable for use in flexible electron devices, touchscreens, and solar cells. Graphene has unique properties such as high thermal conductivity and impermeability, making it valuable in advanced material science and engineering. Graphite is an electrodes of carbon and consists of layers of graphene stacked together. It is commonly used in panels and moderate in nuclear reactors due to its ability to withstand high temperatures. Graphite is a good conductor of electricity and find fullerenes are a class of carbon molecules composed of carbon atoms or in closed case or hollow space. The most famous fullerene is black mixture fullerene C60, which resembles a soccer ball structure. Fullerenes exhibit unique properties such as superconductivity, high strength, and chemical versatility, making them useful in material sciences and nanotechnology. Carbon nanotube. Carbon nanotubes are cylindrical nanostructures made from graphene structures. They exhibit extraordinary mechanical strength, electrical conductivity, and thermal property. CNTs are widely used in chemical processes and instrumental performance. Transformers all the which of the following values used gas in welding? Acetylene is the most commonly used fuel in the welding due to its high flame temperature and stability during combustion. When mixed with oxygen, acetylene provides a flame temperature of approximately 13,000 degrees centigrade suitable for melting. And joining metals, acetylene is used in vessel cylinders containing a porous metal acetone to prevent explosion. Acetylene oxide is widely used for cutting, joining, and metal components, especially in vessels, automobile, aerospace, and construction. Acetylene for industrially formed calcium carbide and water through hydrocarbon cracking process. LPG is a mixture of propane and butane gas commonly used as a fuel for domestic cooking, heating, and some industrial application. Propane, butane. While LPG can be used for heating and cutting, it is not for ideal gas but introduces lower flame temperature compared to acetylene, which burns approximately almost what acid such as when mixed with oxygen, which is instrument holding high yield bonds. Ethylene is a hydrocarbon gas used for primarily in chemical industries as a precursor for producing plastics such as polyethylene. It is not commonly used in welding process due to its lower flame temperature and other chemical properties. Ethylene finds application in agriculture as a plant hormone introduced in ripening fruits. Methane is a primary component of natural gas and widely used as industrial energy gas. It is not preferring gas welding due to its temperature which approximately needs to start when mixed with oxygen. Methane is also used as feedstock for producing chemicals such as ammonia. What is the chemical octane? Gasoline, also known as petrol, is primarily one of the major components of octane. Is a chemical compound with formula C8 acetylene belongs to the ethylene family. Octane rating of gasoline refers to the excess of pinging during combustion, which is caused by the air-fuel mixture primarily igniting an engine. Higher octane fuels are typically used in high-performance turbocharged charge engines for better efficiency and reduction of octane is derived from crude oil through fractional distillations and refining processes. Catalytic cracking methane, the simplest alkyne, and is primarily found in natural gases. It is not a significant component of gasoline due to its low boiling point. At room temperature, methane is used in fuel and liquefied from LNG and compressed from CNG. It is also a major greenhouse gas contributor to global warming. Ethane C2H6 ethane is a hydrocarbon that is also present in natural gas but is not a primary constituent of gasoline. It is commonly used in petrochemical energy for producing ethylene, which is for plastics. Ethane is a gaseous compound under the strength contains vegetable. Propane C3H8 propane is a hydrocarbon used commonly from LPG. It is not a major component of gasoline but widely used for heating, cooking, and methane ethane making hydrogen utilized as fuel in kerosene opinion primarily because it has the highest energy output per kilogram. Hydrogen has the highest energy density per unit mass, approximately 30.6 kilowatt per hour per kg, which is significantly higher than conventional fuels like gasoline. The high energy outputs make hydrogen engine helpful for high thrust and cryogenic engines. Rocket hydrogen is clean fuel and combustion. It is a byproduct making engine friendly. The high energy output of hydrogen is storage of the speeds and thrust ratio outputs, which operate at nuclear hydrogen. It is low boiling point cryogenic engines and their importance. Cryogenic engines are rocket propulsion that use cryogenic fuel such as liquid and oxygen at extremely low temperature. These are critical for specifically as they provide the high thrust needed for launching heavy payloads into orbit. High thermal also make it provide fuel safe for cryogenic engines.